In mathematics, trigonometric substitution is the substitution of trigonometric functions for other expressions. One may use the trigonometric identities to simplify certain integrals containing radical expressions. Substitution 1. If the integrand contains a2 minus x2, let n use the identity substitution 2. If the integrand contains a2 plus x2, let n use the identity substitution 3. If the integrand contains x2 minus a2, let n use the identity examples. Integrals containing a2 minus x2 in the integral we may use. Note that the above step requires that a greater than 0 and cos greater than 0. We can choose the a to be the positive square root of a2, and we impose the restriction on theta to be minus pi 2 less than theta less than pi 2 by using the arcsine function. For a definite integral, one must figure out how the bounds of integration change. For example, as x goes from 0 to a2, then sin goes from 0 to 1/2, so theta goes from 0 to pi 6. Then we have some care is needed when picking the bounds. The integration above requires that minus pi 2 less than theta less than pi 2, so theta going from 0 to pi 6 is the only choice. If we had missed this restriction, we might have picked theta to go from pi to 5 pi 6, which would give us the negative of the result. Integrals containing a2 plus x2 in the integral we may write so that the integral becomes integrals containing x2 minus a2. Integrals like should be done by partial fractions rather than trigonometric substitutions. However, the integral can be done by substitution. We can then solve this using the formula for the integral of secant cubed. Substitutions that eliminate trigonometric functions. Substitution can be used to remove trigonometric functions. In particular, see tangent half-angle substitution. For instance, hyperbolic substitution. Substitutions of hyperbolic functions can also be used to simplify integrals. In the integral, make the substitution